Okay. So have a nice day, everyone. This will be the next sorting techniques or types, which is the quick sort. So let's tackle what is all about quick sort. So quick sort is a sorting algorithm that is based on the divide and conquer algorithm that picks an element as a pivot and partitions the given array around the picked pivot by placing the pivot in its correct position in the sorted array. So our goal here, for example, if you choose a random pivot, you will be going to focus. For example, your pivot right now is R, and your focus is to put R in place. You want to put R where is the specific position. That's how you will do that. And in each partition, you will compare I and J. So, for example, I is your E and your Q is your J, and you have to compare that if E is it lower value with the pivot, you will put that in the leftmost, and rightmost will be put in the it must be greater than the value of the pivot. That's our focus, and we'll begin to illustrate that later on since that is Vegas for now. Now, the steps will choose a pivot, then partitioning that one, and recursively apply the same process. So for choosing the pivot, you can choose random. You can select any pivot from the given array. It depends on your where you will choose that one. And pivot can either be the rightmost element or the leftmost element of the given array. So can be also the median of the array. What when we say median, for example, we have 0, 1, 2, 3. So if you will begin to calculate that 1 0 plus 3 that is divided into 2, that will become 1. So your pivot will be E. Or if you have 4 array, then this will be A, for example. And 0 plus 4, that will become divided 2. So that will become 2. So your pivot right now will be Z. So that's how you will do the median pivot. But here then we will just select the pivot as the leftmost in order for us to be organized and produce the same answer here then. Now, our first partition, we choose 10 as our pivot with that one. So 10 will be our pivot, and this will be our I, and this will be our J. So I will be at the leftmost and the J will be at the rightmost. And our focus, as what I mentioned earlier, that your leftmost must consist, your I must be lesser than the value of your pivot, and your J must be greater than the value of your pivot. If um either of the two, I and J, if it is less than or greater than the pivot, you have to check on the I and J both if there will be something that we can swap with each other so that it will be put in place, organized later on. We'll try to check that one so that you can really understand how what does it mean. Now, using the leftmost as the pivot as 10 in our first partition, this is the first step. This will be your I right now, and this will be your J right now. So I, if you will check, your I is 3, then that is less than to 10. So there's nothing to worry in that one. So keep as is. There's no changes that we can do so. Now for the J, that is 8, and that is less than by 10, our pivot. So our goal is to swap that here then in the leftmost. It must be put in the leftmost so that your those less than value will be switched into the leftmost, what we call this one, leftmost array. Now, you will be going to increment the I and you will decrement the J. So since 8 right now is less than, so you cannot decrement that one since mas tap ka da, and you will check another I that signifies a greater value than your pivot so that you can swap I and J. So 22 is greater than the value of 10 or your pivot. So therefore 22, your I right now, so it must be swapped with your J. So 22, will be here, will be 8, and 22 will be here in your second step. So that's how it works. So 3, um, as what I mentioned earlier, 22 and 8 will be your I and J. So in the third step, 8 is already here and 22 is here. So your new I right now is 45 and J, since you have to increment that one. I is 45, then 45 is greater value than 10. So we need to check something that we can interchange that into the right side. So 41 is greater than the value of 10, so we cannot change that one, just leave as is. So decrement J. So decrement 21 is greater than 10. So that is greater than 10. So therefore, we can decrement right now. So I is 1 and J is 1 right now. And that is less than the value of 10. So therefore, we can swap the I and J. So 45 will be here. As what I mentioned earlier, 45 and 21, then 45 and 1 compare. So we can interchange in the fifth step 1 and 45. So 1 and 45 will be changed to each other, so that will become like that. So right now, our goal is to since there's no other element already, so we stop right there. Since if you will increment your I, so 45 your new I, and J, if you'll decrement that one is your new J. Now, if you will check, if you'll do that, you can interchange supposedly. However, that um collide to each other or cross to each other already, so there's no need to do the that function anymore. So right now our goal is your pivot, we need to put that in place. So where will be the greater value of 10? Before that greater value, you have to put the pivot right there. So since this is a their higher value among their elements that you do have right there, and will be the less than value of your pivot. So therefore, you put right there the 10. So you swap 1 and 10. So therefore, 1 will be here and 10 will be here, and 10 is already sorted and you cannot touch that anymore. So in your first partition, we have 7 steps that we did. Now, the second partition, we will be going to first fix the leftmost before we can do the rightmost. Now, our new pivot will become 1. So your new pivot for the second partition will be 1, and you will check I and J. So your I right now is 3, and 3 is greater than 1, and J is greater than 1. So therefore, you cannot perform any swap. So therefore, keep as is. So 1 right now is already sorted. Now, since it's already done, you can now check another value for a new pivot. So 3 will be a new pivot right now for the third partition. So 3 is our new pivot. Then we have to check I and J. So this is your I and J. So that is greater value, greater higher value to the current pivot. So therefore, there's no changes that we can do so. And so sorted C3 already and put that in a sorted manner already. And 8 will be our new pivot. And since there is no I and J that we can compare, so therefore, automatic sorted C8. Now, afterwards, since we're already done with the left elements, so we can proceed to the right elements already. So 45 will be your new pivot for the fifth partition. So you compare I and J. I will be 21 and your J is 22. So I is less than 45 and J is less than 45. So our goal there, we have to swap 22 to the left side, since that is less than, and this is less than, it's already in place, and this is not in place already. 41 is less than to 45. That's our second step. So second step mo, no, it's not correct. our I must be, yes, that's correct. I mean, so I will be incremented. So ang I ang ma-move, ang J ang di ma-move kay since may interchange na ni supposedly si 22 sa leftmost. However, 41 is less than the value of 45, so we cannot perform any swap. So therefore we can check right there that 45 is less than the value of our 21, 41, and 22. So therefore 22 and 45 will be swapped. So we can swap 45 and 22 is already swapped for the third step, and 45 is already sorted. Now, next position, I'm so sorry, it's not wala na tadlong ang transition ko. So the the fourth partition, sixth partition, I mean, which is 22 is our new pivot, and your I is this 21 and J is 41. So since your I is less than the value of 22, so you stop right, you cannot move that one or do not perform. And a J is greater than the value of 22, so that is already in place. So your goal is to check where we can put 22. 22 is greater than the value of 21, so therefore swap the two. So 21 will be here, this one, and 22 will be here. So we swap that in the second step, and 22 is already sorted. So our new pivot for the seventh iteration partition will be 21, and there's no I already. So there's no I and J. So therefore, it's already sorted. Next partition will be, we choose the 21, and that is sorted already here. And the eight partition will be 41, and we sort that already since there's no I and J, automatic. So that's the end of our quick sort algorithm. That's how it should be. So that's you need to step by step that kind of algorithm. So quick sort algorithm. So if there's any question, you can message or comment down below, and the next videos I'll be going to also discuss the heap sort, shell sort, radix sort, team sort, intro sort, counting sort, bucket sort, and so on and so forth. So however, I'll begin to instruct that in your group chat what will be the final instructions then. So thank you so much for watching, and have a great day.